Everyone, myself Khilosiya, and today me and our group will present the internal evaluation 2 activity that we have implemented. So basically, we have done tomato leaf disease classification using convolutional neural network. So our group members are myself, Khilosiya, Aditya Kolhatkar, and Rahul Kumar. So I'll request Aditya Kolhatkar to start the presentation.
Yeah, thank you, Paras. So, hello, friends. My name is Aditya. So, first of all, let's begin with the data set. So, as you can see in the right hand corner of the screen, you can see the data set mentioned. So, the data set which we have taken is the tomato leaf disease detection data set. So, basically, it is organized into folders with each folder corresponding to a specific type of disease. Uh, so, so let's see, like we have tomato mosaic virus, target spot, bacterial spot, tomato yellow leaf curl virus, late blight, leaf mold, tomato healthy, and septoria leaf spot. So basically, all the folders contain images. So our data set is mainly based on images. So each related to the disease. So all the folders contain images related to the respective disease. So now let's move toward actual implementation. So actual implementation, uh, Paras, can you just scroll? Yeah. So let's begin with train path and valid path. So first of all, train path and valid path. These are just variables that store the paths to the directories containing training and validation. So let's see input libraries. So we have imported all the basic and necessary libraries which are required for the implementation of the our model. So first of all, uh, in import libraries we have imported NumPy, Pandas, OS, Matplotlib, Seaborn, TensorFlow library for deep learning imported. After that, let's see what is data augmentation. I request Paras to just scroll down a little. So data augmentation. So data augmentation is nothing but data augmentation is a basically technique which is used to increase the diversity of the training data set by applying various random transformation to the images. So as a data set is based on images, so this helps the model to generalize better and prevent overfitting. So it avoids the issue of overfitting. So in this we can see we have image data generator. It is used to perform data augmentation. The parameters used in these are train data gen. It includes rescale, shear range, zoom range, rotation range, which all includes applying shear, zoom, rotation, transformation to the images. Brightness range, horizontal flip, and fill mode are also used to adjust brightness. Also, randomly flip images horizontally and to specify how to fill any newly created pixels after transformation, respectively. So after that, we come to data loading. So in data loading, as we can see that image data generator object, it has some parameters. So in that we can see objects train data gen and valid data gen, which are their respective directories. That is, as we have seen in the beginning, train path and valid path. I just request Paras to just scroll little bit above. Paras, please. Yes, little bit above. Yeah, it's okay. So in this, we can see as a flow from directory. This method is used to load images, color mode. So target side used to it is for dimensions to which the images are resized, and color mode, the color mode for the images RGB in our case, and shuffle randomly shuffles the data for images, like we have images data set, and then batch size, the size of mini batches used during training. Seed, a random seed for reproducibility, and class mode. The class mode specifies the type of labels, which is categorical in our case, like categorical data, ordinal data. So in our case, we have categorical and indicating that the classes are not means classes are one not encoded. Like we have one not encoding and label encoding. So in our case, we have one not encoding for use for labeling. Uh, so from here, I request my friend Rahul to take over the session. Thank you.
So, hello everyone, myself Rahul Kumar. So, for the modeling, we have used CNN network, which stands for Convolutional Neural Network, using the Keras library in the Python for image classification. So, first of all, we have initialized the sequential model, which is a linear stack of layers. Secondly, we have added a 2D convolutional layer with 32 filters, each of size 3 by 3, using ReLU activation function. Here, the valid padding means we have added no padding here to the input. So after that, we have used batch normalization layer, which is used to normalize the activation of the previous layer. And after that, we have added a max pooling layer with a pool size of 2 by 2. Here also for we have added no padding. And after the next few lines follow the similar pattern of adding convolutional. So for us, just to scroll down a little bit more. Yeah. So after that, we have used the flattened layer that converts the multi-dimensional output of the conventional layer into one-dimensional layer. So after that, we have added a fully connected layer with 128 neurons and ReLU activation function. And after that, we have used dropout layer with a rate of 0.2, which randomly sets 20% of the input units to 0 and each update during training to prevent overfitting. At last, we have added the dense layer with the number of neurons equals to the number of features. So the here softmax activation function is used for the multi-class classification, as it converts the final layer's outputs into the probability distribution. So after that, whatever we have used in our model, so it's for the summary purpose, we have used that code in which the layer type, output shape, and the different parameters are shown in the summary. So overall, we have used the CNN, that is convolutional neural network, for the image classification. So now from here I hand over to the Paras. Paras, you continue.
Okay. So after making the model, we have compiled the model and check the results. So here you can see we have used 20 epochs for the model training, and after the training we have the validation accuracy and training accuracy. So to start with the training accuracy, so basically training accuracy measures how well a machine learning model performs to the data set it was trained up. So here our data set consists of uh, two folders like training and validation. So from the training folder, we have trained our model and try to find the accuracy based on that particular folder only. And after that, validation accuracy measures how well the model generalized to unseen data. Like here our folder valid consists of the validation data. So here are the graphs for validation and training accuracy for each of the epochs. Monitoring both training and validation accuracy is crucial to ensure that the model learns from the training data without overfitting and can generalize effectively to the new unseen data. So here are all the data. Here I can see the maximum accuracy that is achieved using our model is 96.89, and the maximum validation accuracy is about 94.8. So here is our model. We can see that there is at some cases there is a big difference between our validation and training accuracy. It may be because of the overfitting or underfitting of the model, and that can be prevented or that can be fixed using multiple machine learning techniques such as data augmentation uh, and anything any something else. So this is how we can perform it, and we can make some better model from the given model. Thank you.